In this video, we are going to continue our discussion of double angles, half angles, and now reduction formulas. The double angle formulas can be used to derive the reduction formulas. Okay, reduction formulas, what they are is it allows us to take like a sign that's to a higher power, in this case squared, but we'll see how that's going to work here in a moment. But the idea is to take sine squared and reduce it to cosine to the first power of 2 theta. Like it's kind of weird right now because you don't really see why we need to do this. The reason being is in calculus, it's much easier to do the certain thing called integration on something like this rather than something like that. Okay, so what we're going to do is that's the formula that we just came up with in the other video. And to get these reduction formulas, we're going to solve each one for sine squared or cosine squared. So if I do this, I'm going to minus 1 from both sides. So I get cosine 2 theta minus 1 equals negative 2 sine squared theta. Okay, so we're going to divide by negative 2. Now, when I divide by a negative or multiply by a negative, it flips my subtraction. So I'm going to go ahead and just put the negative on top and flip it. So this is now not over negative 2, it's over just positive. So I let the negative go to the top and change the signs. This leaves me with sine squared. So here's my first reduction formula. It takes sine squared and it breaks it down to cosine 1 minus cosine 2 theta over 2. It's very nice because it took that square and it gets rid of it, which is going to be very helpful when you guys get to Calc 2. Okay, let's do it the same thing for cosine squared. I would add 1. So we get 1 plus cosine 2 theta equals 2 cosine squared theta. And then we're going to divide by 2. So I get 1 plus cosine 2 theta over 2 is equal to cosine squared theta. So there's our formula to reduce cosine squared down to something else. Okay, we can do the same thing with tangent, but we're going to use our new definitions here. I'm going to do a little trick here to get us there a little quicker. Okay, I know that tangent squared theta is equal to sine squared over cosine squared. That's just an identity we've been working with now for a while. But I'm going to go ahead and make things a little easier. I'm going to multiply top and bottom by 2. Since I'm multiplying top and bottom by 2, I'm actually not changing anything. Right? I just multiplied by a 2 over 2, which is 1. Notice, if I take both sides of my equations up here, I can multiply both sides by 2, and I get exactly what's on top and what's actually exactly what's on bottom. So I can just replace now each one. So tangent squared theta is equal to the same thing as 1 minus cosine 2 theta over 1 plus cosine 2 theta. So it does reduce our tangent squared. It got rid of my square, but it introduces a sine and a cosine. So there's our last formula. So these are the reduction formulas. The reason they're called reduction is because it goes from a square down to cosines without any squares. So here are those formulas written out. I like to show you guys where they come from. I won't ask you to do that again for me, but I think it's important that we understand where all these are coming from, and I'm not just like, here are 19 formulas, work with them. Okay, so let's try some examples here. So write the equivalent expression of cosine to the fourth that does not involve any powers of sine or cosine greater than 1. Okay, so what I'm going to do starting off is not write with a highlighter. Cosine to the fourth x. Notice none of these up here had a fourth. It only has a square. So what I'm going to do is cosine squared x, and then I'm going to square that. That's the same thing as cosine to the fourth. Now I can replace that cosine squared with the formula that we just came up with. 1 plus cosine 2x, it's x and not theta this time, over 2. All right? This gets me, okay, up here I'm going to have to do this 1 plus cosine 2x times 1 plus cosine 2x. Remember, this is going to take some foil or a box or however you multiply these out. So first, 1 times 1, inner, and then outer are going to be the same thing. So I'm just going to do 2 of those. 2 cosine 2x. And then the last is going to be cosine squared 2x. Okay, so I get 1 plus 2 cosine 2x plus cosine squared 2x all over 4. We're still not there because it said they wanted cosines to be only in terms of cosine to the first or sine to the first. So I'm going to go off to the side because this is still the issue. So I'm going to go cosine squared 2x, and I'm going to use that same formula that we just used, except for now, let me do something to kind of make it easier for you to get there. Let's call this a u. Okay, cosine squared of u, we know this definition, we just used it. This is 1 plus cosine 2u over 2. Well, if I replace u now, remember u was 2x. So it's 1 plus cosine of, okay, not 2u, but 2 times 2x, which is 4x over 2. Okay, so that gets me 1 plus 2 cosine 2x plus, okay, and then we get this fraction here. I'm going to go ahead, we'll leave it. 1 plus cosine of 4x over 2. And then everything is divided by 4. So now what we're going to do is divide everything by 4. I get 1 over 4 plus this 2 over 4 gets me a half, so I get cosine 2x over 2. And then I'm dividing by 4. It's the same thing as multiplying by a 1 over 4 right here. So this is going to give me a 1 plus cosine 4x over 8. Okay, it's a lot, but we're going to actually use that. I got everything down to just cosines to the first power, so cosine to the fourth is the same thing as this. Now, the reason we're doing that was practice to work with the formulas, to get it down to that, but now we're actually going to use that to prove an identity. Okay, so look at this next problem. It's pretty gross. Use the power-reducing formulas to prove that 10 times cosine to the 4x is equal to that long expression there, 15 over 4 plus 5 cosine 2x plus 5 over 4 cosine 4x. So I'm going to start. It makes most sense right now to start with the left side. If I were starting this problem for the first time, I probably would have started on the right side because it's more complicated. The reason I'm going to start on this is because I just figured out what cosine 4x was. So I'm hoping it'll work out for us if I use it. Right? I'm going to be lazy here and duplicate. I think you guys will have to rewrite. So it's 10 times all of that. And I'm trying to show that this is equal to what I have circled there. So 10 over 4, that becomes 5/4. I'm on the way. Plus, okay, and then I get 10 times, and this 10's going by everything. That's what I'm doing right now. 10 over 2 gets me that 5 cosine 2x. 5 times we get here. I'm going to rewrite this above here. This is 1 over 8 plus cosine of 4x over 8. I can split things like that when I'm dividing by one term. This is still being multiplied by 10. So I get 10 over 8 plus, and then 10 over 8 is going to reduce. I'm going to go ahead and reduce this one. We get 5 over 4 cosine 4x. We're almost there. The only thing left is to add this and that. That's just a 5 over 4. So we end up getting a 5 over 4 plus 5 over 4 is 10 over 4. Where's our last number? That may be a mistake. Where did it happen? Oh, that's because I didn't multiply this correctly. Some of you guys probably even noticed that. This is 10 over 4. There we go. 10 over 4. This ends up being 20 over 8. Which means I'm going to add it together and get 30 over 8. But if I reduce that, that's 15 over 4. So we did it. So I'm going to replace now. 15 over 4 plus 5 cosine 2x plus 5 over 4 cosine 4x. That's exactly what we were trying to prove. All right, so this is pretty nasty. There are a lot of numbers flying around. I would encourage you to, I think the hardest part really is just the arithmetic from this step to that step, not really the trig. I think it's just the weird fraction business. So I would encourage you to try that, try to match this answer. Make sure you're not just like, oh, I can do that, because if it shows up on a test, You got to be able to do it, all those numbers in the arithmetic. And this is kind of that thing I was talking about, that this is the hard part of calculus, is this arithmetic type business. Please trust me that is true. Put in the work now to be able to do these complicated algebra problems. Or it's really not algebra, but arithmetic.